Digital Design and Computer Organization Lab Tutorials. In today's, I am Sahana RS, Assistant Professor, Department of Information Science and Engineering, Rajiv Institute of Technology, Hassan. Today, we shall discuss about fourth experiment, that is, design a Verilog HDL to implement binary adder subtractor, half adder and full adder, and also half and full subtractor. The aim of this experiment is to design an half adder and full adder, and also half adder, half subtractor and full subtractor to perform binary addition and binary subtraction. First, we shall know what is adder and subtractor. Binary adder is a kind of digital circuit which is mainly used for executing an arithmetic operation of two binary numbers, that is addition. To perform an addition, we use a digital circuit called as binary adder. This binary adder can be of two types. One is half adder and the other is full adder. The half adder performs the addition of two bits, only two binary bits, to give an two output. One is sum and other is carry. Next we have is full adder. Full adder performs addition of three binary numbers. The full adder inputs are two inputs A and B, and also the third input is carry in from the previous input. That means we add three binary numbers to get two output. One is sum and the other is carry. Similarly, subtractor is the binary circuit which is used to subtract two digital number. The subtraction is nothing but addition of a number to 2's complement of another number. The subtractor is of two types, half subtractor and full subtractor. The half subtractor is used to subtract two single bit digits. It includes two inputs and two outputs. Inputs are A and B, whereas outputs are borrow and difference. Full subtractor is similar to full adder. It has three inputs. It is used to subtract three inputs, that is A, B and borrow in. The outputs are borrow and the difference. Now let us get to go through the program of this half adder, full adder, half subtractor and full subtractor. Before going to the program, we should know what is the logic applied between input and output to get sum and carry. So this figure shows the truth table of your half adder. Okay, when 0 is added with 0, the output is 0 for sum and also carry is 0. When 0 is added to 1, the sum is 1 and carry is 0. When 1 is added to 0, the sum is 1 and output carry is 0. When 1 is added to 1, the sum is equal to 0 and the carry is equal to 1. If you draw a K map to this, the equation of sum is equal to A bar B plus B bar A, which is similar to A XOR B. The sum of half adder can be expressed using an XOR gate, whereas carry is equal to 1 only at A is equal to 1 and B is equal to 1. Therefore, the equation for carry becomes A and B. The circuit diagram for half adder is as shown in the figure. It uses one XOR gate to obtain sum and one AND gate to obtain carry. So now we shall write a program. We already know the logic. A XOR B gives us sum. A and with B gives us carry. So we can use data flow modeling to write this half adder. Okay. Here every program starts with a keyword module and ends with a keyword end module. Okay. We need to specify the inputs and outputs. Here inputs are input A and B. Output is S and C. S refers for sum and C refers for carry. Here we are using assign keyword to assign sum is equal to A XOR B and carry is equal to A and B. So which gives us an output of half adder. See the construction of full adder. The input for full adder are A, B and C in. We have three variables, therefore we have 8 combination. The sum and carry out are the outputs. Sum is equal to 1 when we have any one of the input is equal to 1 and all the 3 input are equal to 1. The carry is equal to 1 when we have 2 inputs is equal to 1 and all the 3 inputs is equal to 1. The equation for full adder is shown here. The sum is equal to A XOR B XOR C in and carry out is equal to AB plus BC in plus AC in. The circuit for full adder can be constructed using two half adder. The two half adders includes two XOR gates and two AND gate. The full adder requires two XOR gate, two AND gate and one NOR gate. The construction of full adder is shown here. The program for full adder is shown here. Again we have to write a module, name of your program. We need to specify inputs and outputs. Inputs are A, B and C in. The outputs are sum and carry. Sum is related to input as sum is equal to A XOR B XOR with C in. Whereas carry is equal to A. First A is AND operated with B. Then C is AND operated with A and A XOR B, then the both is given to OR gate to find C out. Now similarly let us see the half subtractor and full subtractor. This truth table represents the half subtractor. 0 subtracted with 0 gives us 0 difference and borrow is also 0. Then A is equal to 0 and B is equal to 1. 0 subtracted with 1, the answer is 1 and the borrow is also equal to 1. Then 1 subtracted with 0 is equal to difference is 1 and borrow is 0. When 1 is subtracted with 1, the difference is 0 and borrow is also 0. This means the difference equations are given as A bar B plus AB bar, that is nothing but A XOR B, and again the borrow equation is equal to A bar B. The circuit diagram for the half subtractor is shown here. The HDL program here, the inputs are A and B, output are differences and borrow. We need to assign difference is equal to A XOR B and C is equal to not of A and operated with B. The truth table of full subtractor is shown here. The difference are equal to 1 only when any one of the input is equal to 1 and the difference is and all the inputs are equal to 1 and the borrow is equal to 1 when C is equal to 1 and all the other two inputs are equal to 0 and B is equal to 1 and other two inputs are equal to 0 and BC is equal to 1 and A is equal to 0 and when all the inputs are equal to 1. When we draw the K-map for the above truth table, we will get an equation for difference as A XOR B XOR with C and difference of full adders borrow is equal to A bar B plus BC plus A bar C. So again here also we declare which are all the inputs and outputs and we are going to assign difference is equal to A XOR B XOR C and borrow is equal to A bar is represented as not A and operated with B. Then OR operation is indicated with a pipeline. not of A x A XOR B and with C. This the equation can be read.
Double click on ISE design suite, file, close project, file, new project, check for the folder should be in the Xilinx, give the name of a project. Now okay, you can give any name. We are designing a half adder, so I have named it as half adder. Click on next, next, finish. Then right click on this XCS new source, select Verilog module, give the file name, click on next. In half adder we have two input A and B, output sum and carry. Change it to output, click on next, finish. After this we need to write the program. Okay, if you use small letter, then you have to use small letter in the program also. Next, the procedure to be followed is right click on this. Okay, first save this, double click on synthesis, then after getting a green tick, right click on half adder, new source, select VHDL test bench, give the name for test bench, next, next, finish. After this, go to simulation, select your test bench, double click on behavioral check syntax. Sorry, you have to click on UUT, then you have to check for behavioral check syntax. Click on simulate. If you are having two input, the force clock should be running till 4 picoseconds, leading edge 0, trailing edge 1, cancel time should be 4 picoseconds and the period should be 4. Apply, then select B as your input, give 2 as the period, apply OK, then run. You can observe the sum for input 0 0 is 0 and carry is also 0. For 0 1, this is 0, this is 1. For 0 1, sum is 1, carry 0. For 1 0, sum is 1, carry 0. For 1 1, sum is 0, carry 1. Now let us execute the full adder using ISE design suite. Double click on ISE design suite, file, close projects, file, new project, give the name as full adder, click on next, next, finish. Now right click on XCS new source, select Verilog module, give the name as full adder. A full adder contains 3 input A, B and C input and output as sum and carry. Okay, so sum and carry are output, change the port to output, click on next, finish. Okay, this is a program for full adder. Now Let us check the syntax. Save it. Synthesis. There are no error. Then we have to create a text bench. Right click on full adder, new source, Verilog test bench. Name the test bench. Click on next. Finish. After a test bench is created, go to simulation. Click on UUT. Behavioral check syntax. Simulate the program. Here, as I told earlier, we have 3 inputs. So, force clock should be run till 8 picoseconds. So, leading edge is 0, trailing edge is 1. So, the program has to run till 8 picoseconds. Then input is 8. Apply, OK. So, select B as another input. Same leading edge 0, trailing edge 1. It has to run till 8 picoseconds with 4 period. Apply, then change it to C. Change the period to 2. Apply, OK. Then run the program. Okay, you can observe the output. For combination 0 0 0, the output is 0. For combination 0 1 0, the sum is 1, carry is 0. For combination 1 0 0, we have sum is equal to 1 and carry is equal to 0. You can cross check this with the truth table you have entered. Similar to half adder, we can also design half subtractor. All the procedures are same except this, we have a difference is equal to A XOR B and the borrow is equal to not of A and B. In addition, we used A XOR B for the sum and A and B as a carry. After writing this, run the program, check for any error. If no error is found, create a test bench. Then after creating a test bench, click on UUT, check for the behavioral check syntax, then simulate the program. Give the force clock, leading edge 0, trailing edge 1. It has to be cancelled after 4 picoseconds with a period 4. Apply, next change the input to B, change the period to 2, apply, OK. Run. You can observe the output of half subtractor. You can cross verify it with the truth table you have entered. Similarly, you can execute the full subtractor. Here is the program for the full subtraction and this is the waveforms. Okay, you can cross check the waveforms using your truth table. Okay, let us check once. For 0 1 1, this difference is 0 and the borrow is equal to 1. For 0 1 1, we have difference is equal to 0 and borrow is equal to 1. Similarly, you can check all the combinations present over here.